Hello everyone and welcome to my video for segments and midpoints. Right now we're looking at page 41 in our books and we're going to do problems 6 through 9. So let's take a look at some definitions they have here. The midpoint of a segment is the point on the segment that divides it into two congruent segments. For example, if B is the midpoint of AC, then AB is congruent to BC. So let's take a look at what we got here. Basically, a midpoint cuts a line segment in half. This original entire line segment was 6 units big, and then when they threw the midpoint in here, it cut it into half, and half of 6 is 3. So it went from being 6 total to each of the halves being 3. So that's what congruent kind of means. Congruent means that some object is the same as another object. So in this case, they say AB is congruent to BC. Objects can be congruent to each other, but numerical values cannot. So what I mean by this is, if I wanted to write this, when you're doing a segment like they have over here, I'll rewrite it, right? AB, when it's a segment, we put that line on top. BC, again, a segment, we put that line on top. That goes and kind of creates this line segment, right? And that means we're talking about an object, an actual line segment. And since they're both 3 units big, they are congruent, right? They are the same line segment, same size, right? They might not be the same exact one as one's AB, one's BC, but in terms of, what they look like, they're congruent, they're the same. So if I'm talking about the actual measure of a line segment, I would say, AB equals 3, right? When there's no line on top, that basically means I'm not talking about the line segment itself. I'm talking about the measurement of that line segment. Same thing. If I say BC equals 3, I'm saying the length of that line segment is 3. I'm not saying the line segment equals 3. It's the length of that line segment equals 3. So I can say that AB equals BC. I can say that because they are the lengths of the line segment, and 3 equals 3 because they're both equal to 3 units. What you cannot do is I cannot say that AB is congruent to BC. That is not true, right? Those are AB without that line is just 3. Same with BC. I can't say 3 is congruent to 3. That's not how it works. And, equally, I can't say that AB equals BC. Right now I'm talking about the line segments. Objects cannot be equal to each other. Okay, so when you're talking about the object itself, then it has to be congruent. If you're talking about the length of the object, it has to be equal. So this is something that people mess up a lot. So I just wanted to make sure that, we kind of talked about it. So if it does come up, you know what's going on. All right, so let's take a look at number 6 here. It says if RS equals 10, then SM equals. So what I find is helpful is drawing a picture, right? And you have to kind of read this right here to draw that picture. Given M is the midpoint of RS. So RS is going to be a line segment, so I can go ahead and draw a line segment. All right, it starts at R and ends at S, and it didn't really matter which side was which. I could have put S on the left and R on the right. And it says M is the midpoint. So the way you do this is you try to find the middle as much as possible, right? We can label that M. And then, what I like to do is if we know that a line segment is the same length as another one, then we use what's called like a little tick mark. Right, so I use 1 tick mark for this line segment up here, and that tells me that AB is the same as BC. Right, if I have 2 tick marks, now they're not the same. Right, AB would be its own thing, BC would be another, but if they both have 2 tick marks, then they're again going to be the same thing. So whenever you're doing line segments, you can use tick marks to say which ones are the same or congruent as each other. And however many tick marks, all the ones with that same amount are going to be congruent. So down here, I know that those two sides are going to be the same because it's a midpoint, so it cuts it in half, right? It cuts it into equal pieces. So RS is 10 units long. So that's the entire line segment. So if you wanted to, you could kind of label that. Maybe you could put like this thing up here and say that that whole thing is 10. But what's more important is now, okay, if that's 10, then what happened when I put that midpoint in? Well, it cut the line segment into two equal sides, half of 10 being 5. So I cut this line segment into two 5-unit big pieces. RM is 5 long, and MS is also 5 long. MS and SM are the same thing. So I know that SM is 5 units big. Again, I suggest drawing a picture. I think it's helpful. Same with B here. Right? I'm going to draw the picture because this is when it starts getting a little tricky. For A, it was giving us the whole line segment as 10. We cut it in half. Each side was 5, and then we put that as our answer. If you don't know how I got to 5, you could just divide 10 by 2. Same thing here. Right? Idea-wise, we're given numbers and midpoints and all that good stuff, but it's going to change up a little bit. So I'm going to go ahead and put the midpoint in here. And it doesn't have to actually be right in the middle. I think it looks a little off. That's no big deal. And they tell us, and again, label, R and S. Doesn't matter which one's which. And it tells us RM is 12. Now, again, I know that these two segments are going to be the same, so I can give them the tick mark. RM is 12, so I can label that 12, and that also leads me to know that the other half is also 12. And if RM is 12, MS is 12, because it cut it into two perfect halves with that midpoint. So that kind of answers this part here. I know that's 12, and then RS is the whole thing. So you need to add the two pieces together. 12 and 12 brings us to 24. All right, so that right there is how we can use midpoints to find different segment lengths of, larger segments and all that good stuff. So if you have any questions on that, make sure you join a Zoom and ask them. Let's take a look at then the check your understanding here. It says points D and E are aligned on a ruler. Point D is at the mark for 4.5 centimeters. So let's take a look. I have a ruler here. I'll go ahead and mark it at 4.5 centimeters. And the distance between D and E is 3.4, at which two marks on the ruler could point E be located. So I'm going to label this D. So basically what this is saying is I need to go 3.4 centimeters to make E. Right? So 3.4, so I can go over, 1, 2, 3, and then 0.4, and that would bring me right here to E, which would be 7.9 centimeters, right at the line for 7.9 centimeters. But I didn't have to go to the right there, right? I could have also went to the left. So again, I'm going over 3.4, so I got 1, 2, 3. And then 0.4 would bring us to, 1.1. All right, so, oops, and let me label this as E, and that's at 1.1 centimeter. All right, so if I started at 4.5, I could have either subtracted 3.4 and went to the left and got 1.1. If I subtracted that length, or I can add the length of 3.4 centimeters, and that brought me to 7.9. So E could have been at either one of those two spots on the ruler. And that's what the answer wants, which two marks of the ruler could E be located right there, 1.1 centimeters or 7.9 centimeters. All right, point N is the midpoint of FG. We're looking at number 8 now. That was number 7. We're looking at number 8. So we did this one. Point N is the midpoint of FG. So again, I like to draw things out. I don't give you too much room here. That's okay. FG, so I label that segment as F and G, and then the midpoint is N. I know these two sides are the same. It says Fn is 2x, so that's going to be this half. That means the other half is also 2x. Right? They're the same. So if Fn is 2x, Ng is 2x. What expression represents Fg? Well, I could just add those two halves together, right? So Fg is going to be equal to, 2x plus 2x, and that would give us 4x by combining like terms, or they're both x terms. So if I have two of them plus another two of them, that gives me a total of 4x, which is now Fg, or the expression for Fg. Number 9. Number 9 says, does array have a midpoint? Explain. So array starts at one point and goes forever in one direction. No, there's no midpoint. Right? This is infinitely long, so there's no way of finding a halfway mark. So nope, there's no midpoints on arrays, and we're not worried about number 10. So I'm going to go ahead and stop this video here. I'm going to make another video for some more problems, but I'll keep them nice and small, so they're not too long for each video.